Enterprise networks today are processing thousands of AI-generated interactions every minute. But when executives want to know if this deployment is actually working, they typically look at standard IT performance dashboards. These screens are filled with vanity metrics: total user logins, daily prompt volume, or the raw number of documents the system generated. These numbers track activity. They confirm the software is on and employees are clicking buttons. An initiative can produce charts with steep, upward trending activity curves while simultaneously generating zero financial return for the company. Measuring AI purely by its activity level creates an illusion of success. 6 months later, when the system cannot prove its financial impact, the board cuts the funding. To evaluate AI effectively, leadership teams have to abandon the standard IT deployment mindset and adopt the capital allocation mindset of a chief financial officer. An enterprise AI rollout is a formal investment hypothesis. You are testing whether committing capital to this specific tool will yield a measurable business result. Proving that hypothesis requires moving past flat dashboards and building a multi-layered measurement framework. This framework mathematically links raw technical performance at the bottom, through human behavior in the middle, to actual business outcomes at the top. Without this unbroken chain of evidence, every claim of AI-generated value is purely anecdotal. The evidentiary chain begins at the base layer with process metrics. The operational purpose here is strict technical validation. This layer proves the AI model functions exactly as designed. It tracks specific indicators, like the retrieval precision for a knowledge assistant or the exception rate within an automated routing workflow. But technical performance cannot stand alone. An AI model can retrieve perfectly accurate data in microseconds, but if it sits isolated on a server, it changes nothing. A flawless AI system is a mandatory prerequisite, but it guarantees absolutely no financial value on its own. To connect technology to value, we need the middle bridge: adoption and trust metrics. This layer tracks human behavior. It measures whether workers are actually shifting their habits to integrate the new tool into their daily operational workflows. The required metrics here are highly specific to the user. We measure active usage rates in target workflows, the frequency of manual overrides, and measured human confidence scores. This exposes a common failure pattern in enterprise AI. The technical process metrics hit their targets, but the adoption metrics fall flat. Excellent technical capabilities paired with poor adoption means the organization has purchased a highly capable system that the staff does not trust enough to use. When the system works and the humans use it, we reach the apex of the stack: outcome metrics. This is the only layer in the entire framework that proves the original investment hypothesis was correct. Looking at this matrix, the primary value metrics row shows how different quadrants require entirely different business outcome measurements. Instead of counting prompts, these metrics track hard operational realities: verifiable time saved per task, direct operational costs reduced, or specific improvements in proposal win rates. Because these figures depend on widespread adoption and actual workflow completion, outcome metrics take the longest of the 3 layers to manifest in the data. If the outcome layer cannot be validated with hard numbers, the entire AI investment hypothesis has failed, regardless of how impressive the technical dials look. Once the KPI stack produces validated outcome data, we can move from theoretical measurement to rigid financial design. At the board level, ROI estimates must adhere to a strict rule. They are always built on conservative assumptions. This means calculating the return using the lowest bound of expected benefit, weighed against the highest bound of realistic cost. Finance leaders utilize a standard framework for this calculation. Return on investment equals the net benefit divided by total cost multiplied by 100. That net benefit variable is derived by taking the estimated gross benefit and subtracting the total cost. An AI business case built upon these constrained mechanics is the only kind robust enough to survive intense executive skepticism and everyday operational friction. We can see how this works in a practical enterprise scenario, pulling verified data straight from our outcome metrics layer. First, we establish our baseline gross benefit. Let's say the verified time savings translate to a conservative estimate of $100,000 in value. Next, we factor in the fully loaded cost. This includes governance, training, and data preparation, not just software licensing, bringing our total cost to $40,000. Subtracting that gives us a net benefit of $60,000. We execute the final calculation. $60,000 divided by $40,000 multiplied by 100 yields an ROI of 150%. This figure holds up in the boardroom because it is directly supported by the unbroken process and adoption layers sitting directly beneath it. By discarding vanity metrics and utilizing a rigorous KPI stack with conservative math, organizations transform AI into a highly